produce more than 100%, we store the remaining. If we don't get enough from the solar field to work at L, then we go to the tanks and see if we have enough to complement to reach the L level, okay? And we have to take into account also ambient losses in the tanks along the hours. And if there's not enough coming from both the solar field plus the tanks, then we see if we can use the auxiliary system. And we can use it if the accumulated percentage will not go beyond the 15%, okay? If we can use it, we use it. If not, we stop. And then we store whatever was coming from the solar field, and we stop. And we have to take into account also that after 8 or more hours stopping, the next working hour, the electricity produced is devoted just to restart the system, so it won't be sold. We have to take this into account. So all this is completely impossible to model with functions, so we had to use a black box where we programmed all this working strategy. And this black box had as inputs the values of the variables, and at output some variables that allowed us to keep track of the important things, how much energy is stored after each hour, which is the fraction load we're using at each hour, how much we use the auxiliary system, and which is the accumulated percentage of the auxiliary system. Okay? And with this outcome, we can calculate the yearly profit, taking into account everything and selling at a fixed selling price that is set by the government. Okay? And we also had into account some fixed costs and some variable costs that were basically the cost of the fuel when we are using the auxiliary system.